mathematics on Oxygen FM 96.9. I warmly greeting all our parents, teachers, and their students. My sincere appreciation goes to our producer, studio manager, and the entire management of Oxygen FM 96.9 for making this program possible. My name is Muyiwa Ogunrinola, and I am your presenter. Get your notebook, pen, and calculator ready to work to make mathematics simple, practical, and enjoyable. Stay tuned as we begin the lesson. You are welcome to Mathematics on Here. Today we are going to start with indices. We are going to look at what are the indices. As some example, the law of indices. Let's quickly dive into it. Indices provide a way to write number in a more compact form. An index. Indices provide a way to write a number in a more compact form. And an index is often called a power. What are the indices? Indices provide a way of writing number in more convenient form. Indices is a plural of index. An index is often referred to as a power. For example, I want us to take us back to our previous knowledge in index number. Because I said the plural of what index is indices. Now from our previous knowledge, maybe when you are in SS1 or you are in primary school, you may have something like this: 5 times 5 times 5 in 3 places. They ask you to write it in index number. Then you will pick 5 raised to power 3, meaning that we have 5 in 3 places. So to write it in index form, it will be 5 raised to power 3. Another example is when you have 2 in 4 places. That is 2 times 2 times 2 times 2. You can see that we have 2 in 4 places. To write it in index form, it will be 2 raised to power 4. Likewise, when you have 7 in 5 places, you will see that you write it as 7 times 7 times 7 times 7 times 7. So in index form, it will be 7 raised to power 5. And in that case, when you look at the 7 is the base. And then the 5, it is what? It is power. That is 5 raised to power 7. So you can now see from these 3 examples, we have 5 raised to power 3, 7 raised to power 4, and 2 raised to power 7 raised to power 5, and 2 raised to power 4, and in index form. All this one are in index form. But now let's look at it if we combine the 2 together. Okay, you can see it now. Let's look at it if we combine the numbers together. We see 5 times 5 times 5 times 2 times 2 times 2 times 2. You can see that you have 5 in 3 places multiplied by 2 in 4 places. So in writing this one, it will be 5 raised to power 3 times 2 raised to power 4. In this case, you cannot solve further because the base are not the same. But when you put the 2 together, you can only see it that 5 raised to power 3 times 2 raised to power 4. We are going to leave it like that because it is what? You cannot simplify it further in what? In indices. So now let's quickly dive into the word to look at some laws of indices. Laws of indices. Now the first one here, we have a multiplication law. And under this law, when you have a raised to power m multiplied by a raised to power 9, you can see that the two of the power, the two of index number have the same base. So in that case, you are going to pick only one base, and mind you, it is multiplication. Then you will now add the power together. So for multiplication law, it will now be a raised to power m times a raised to power n. So this one will give us a raised to power m plus n. You pick only one base, then you will add the power. You add the power. Now, for example, on this multiplication law of indices, when you have 2 raised to power 6 multiplied by 2 raised to power 4. Now, we have the same base. It has the same base, 2 raised to power 6, then 2 raised to power 4. Then you are going to pick 1, 2 because they have common base and add the power together. It will now be 2 raised to power 6 plus 4, which is going to give us 2 raised to power 10. That is if it has to leave your answer in index form. But if you want to simplify it further, then you can now press your calculator to look at the 2 into 10 places, then write the final answer. Another example on this multiplication law, we have 3 raised to power 5 times 3 raised to power 7. This one also, it has the same common base. And in this case, you are going to pick only one base, then add the power. So this one will now be 3 raised to power 5 plus 7, which is going to give us 3 raised to power 12. 3 raised to power 12. Another law that we want to talk about is division law. Division law. This one is the same thing, is opposite side of multiplication law. When you have a raised to power m divided by a raised to power n, this one also have common base. Then you pick only one base. Instead of division, then you subtract the power. So that you are going to write it as a raised to power m minus n. That is be our general formula for division of what? For division law. For example here, when you have 2 raised to power 6 divided by 2 raised to power 4, this one will also give you 2 because they have 2 as common base. Then you subtract the power, which is going to be 6, 2 raised to power 6 minus 4. When you remove 4 from 6, it is going to give you 2 raised to power 2. And this one, it will be what? That is when you ask to leave your answer in index form. But if you are to simplify it to write the final answer, it are going to be 4. That is 2 raised to power 2 means 2 times 2 times 2, which is equal to what? 4. Now, another example there, when you have 3 raised to power 5 divided by 3 raised to power 7. 3 also, they have what? They have the common base. Then it's going to be 3 raised to power 5 minus 7. This one is going to give you 3 raised to power minus 2. Another way, you can still write it as 1 over 3 raised to power 2, which is going to give you 1 over 9. So the another one we still need to look at is a bracket law, or we talk a power of power. Yeah. When you have the a raised to power m all in bracket raised to power n, a raised to power m in bracket raised to power n. So in this case, you see that we have 2 power there, e raised to power m, a raised to power m inside the bracket, and outside the bracket again is still raised to power n. In that case, this one is going to be multiplied because the bracket there simplify multiplication. So this one will now be a raised to power m multiplied by n. There is difference between this one and multiplication law. Don't forget, in multiplication we had the power, but in this case you are going to multiply the power because it is power of power. A raised to power m, inside the bracket and also raised to power n. You are going to multiply the power together in this case. For example, you have 2 raised to power 6 all in the bracket, then raised to power 2. 2 raised to power 6 inside bracket and raised to power 2. In solving this one, you can expand it. Write as 2 raised to power 6 times 2 raised to power 6. This one have lead us to multiplication law. Now this one will now be what? 2 raised to power 6 plus 6, which is equal to 2 raised to power 12. Or you do it in this way: 2 raised to power 6 multiplied by 2. You are still going to get the same answer. Now another example, there is 3 raised to power 5 all in brackets, then raised to power 3. You can also simplify this one in 3 places because the outside power, it is 3. So you can now write it as 3 raised to power 5 times 3 raised to power 5 times 3 raised to power 5. Now you now write 3 raised to power 5 plus 5 plus 5. You add all the power together and it gives us 3 raised to power 15. Now another law here, you still have what they call zero law or index of 0. When you have a number raised to power 0, where you have a raised to power 0, is going to give you 1. So any number raised to power 0 is equal to 1. For example, here when you have 3 raised to power 5 divided by 3 raised to power 5, you see they have the same base, then they have the same power. Then when you pick one base, it will now be 3 raised to power 5 minus 5. This one will give you 3 raised to power 0. And 3 raised to power 0 is what? Is 1. So that is it. In this law, any number that raised to power 0 will give you 1. Then we still have a power law here. Power law, or we call it the root. The root. When you have a raised to power m divided by n, you can see it that a, the raised there what is in fraction. M on top is the power. The n that it is what? It is root. So in this case, if you want to write this one, it will now be cube root of m into a. It will now be what? You write the cube root, you put m outside and the a inside the cube, then everything raised to power x. Meaning that if you want to solve something like this, you firstly take the cube root of a, then when you get your answer, it will now raise it with power. You raise it with power. For example, here we have 16 raised to power 3 over 4. When you have 16 raised to power 3 over 4, now in this case, you put 16 inside the cube root and put 3 outside. That will now be cube root of 16. Everything in bracket raised to power 3. And when you look at that 16 there, you will see it that there will be a particular number here that, okay, 4, sorry, it did that cube root. Now it will be what you put 4 outside and put 16 inside, then it will raise to power 3. What does that one mean? It means that 4 that is outside, it says something that 16 inside that root. There will be a particular number. When you multiply it in 4 places, it will give you 16. And when you look at that, you see that it is 2. When you say 2 times 2 times 2 times 2. Now when you multiply it together, it will give you what? 16. So in that case, it will now be 2 inside that bracket raised to power 3. So our final answer there will now be 2 raised to power 3 is equal to what? 8. Or another way of solving that one is you can write 16 raised to power 3 over 4. Now, when you look at this one, that 4 that divide the 3 in the power, there is a particular number that you can multiply it together in 4 places that will give you 16. The same thing. It will not be 2 raised to power 4. You know, 3 raised to power 4, it is outside the bracket before. You now multiply it by that 2 raised to power 4 multiplied by 3 raised to power 4. So 4, we cancel 4. You are still going to have 2 raised to power 3. And 2 raised to power 3 is what? Will give us 8. Now, we still have law that has to do with the fractions. Has to do with fractions. When you have a raised to power minus m, a raised to power minus m. To write this one, it will just be 1 over a raised to power m. 1 over a raised to power m. So, for example, when you have 2 raised to power minus 3, 2 raised to power minus 3. In that case, this minus is going to turn to 1 over 2 raised to power 3. So, in writing this one, it will now give us 1 over 8. 1 over 8. So, that is this one. So, another thing is that let's look at the some examples here. Let's look at the some example. If we put all these things, if we put them together, for instance, now let's look at this one. 2 raised to power 6 times 2 raised to power 4 divided by 2 raised to power 3. 2 raised to power 6 times 2 raised to power 4 divided by 2 raised to power 3. Now, in solving this one, for the numerator, you have 2 raised to power 6 multiplied by 2 raised to power 4. You have the same base. Then, that one will give us 2 raised to power 10. You are going to add the power there. That is 2 raised to power 10 divided by 2 raised to power 3. Mind you, I told you earlier that division law for indices, when you are to divide and they have the same base, then you need to what? You need to subtract. You are going to subtract. And when you look at the numerator now, it is 2 raised to power 10 then divided by 2 raised to power 3. You see, 2 of them has common base. Then you are going to pick 1, 2. It will now be 10 minus 3. That division will change to subtraction. It will now be 10 minus 3, which is going to give us 2 raised to power 7. Another one is 3 raised to power 5 times 3 raised to power 7 divided by 3 raised to power 4. You can see that all these index number has the same base. But for the numerator, you are going to pick one base, then add the power. So it will give us 3 raised to power 5 plus 7, which is going to give us 3 raised to power 12, divided by 3 raised to power 4. So, because the 2 of them have the same base, then you pick only one base, which is 3. It will now be 3 raised to power 12 minus 4, which is going to give us 3 raised to power 8. Now, another one we can still look at in that place is 2 raised to power 5 times 2 raised to power 3 divided by 2 raised to power 4 times 2 raised to power 2. Now, 2 raised to power 5 times 2 raised to power 3 divided by 2 raised to power 4 times 2 raised to power 2. If we solve the numerator first, it will be 2 raised to power 5 plus 3 divided by 2 raised to power 4 plus 2, which is going to give us 2 raised to power 8 divided by 2 raised to power 6. Then you subtract because they have common base. This one will now be 2 raised to power 6 raised to power 8 minus 6, which is going to give us 2 raised to power 2. 2 raised to power 2. Now, another example here, when you have the number with algebra functions, and you have 2a raised to power 3 times 3a raised to power 4. We see this one that you have a number and algebra. 2a raised to power 3 times 3a raised to power 4. In solving this one, you are going to put all the odd number together. You separate the number. So it's going to be 2 times 3 times a raised to power 3 times a raised to power 4. Now, when you look at this one, you see that 2 times 3, they are different number. So in that case, you are going to add it to and multiply it together. 2 times 3 will give us 6. But for a raised to power 3 times a raised to power 4, we see that they have the same base. So in this case, you are going to pick only one a, then you add the power. So it will now be a into raised to power 3 plus 4. This one will now give us a raised to power 7. So our final answer will now be 6a raised to power 7. Another one for division here, when you have 8a raised to power 6 divided by 4a raised to power 4. Now we are going to do the same thing we did in the previous examples, because 8 and 4, they are not the same. So in that case, we are going to use 8 divided by 4. Then we gather a raised to power 6 and a raised to power 4. We divide that one too. So it will now be 8 divided by 4 multiplied by 8 raised to power 6 divided by 8 raised to power 4, which is going to give us 8 divided by 4 will give us 2. And a raised to power 6 minus divided by a raised to power 4. That one, we pick only one base, then you subtract the power. So when you remove 4 from 6, then it will give us a raised to power 2. So our final answer here for this one, it will now be 2a raised to power 2. Okay, you are welcome back. Let's really take one more example before you have the access to call in to ask your question or to answer my question if you are listening to me. Now, when you have another question we want to solve now is 27 divided by 125. Everything inside bracket raised to power 1 minus 1 over 3. I'll say it again. 27 divided by 125, all in bracket, raised to power minus 1 over 3. Multiply by 4 over 9, all in bracket, raised to power 1, raised to power minus 1 over 2. Again, 4 divided by 9, all in bracket, raised to power minus 1 over 2. So when you see this question, you see that the 2 has negative in their power. Now to solve this one now, solution, let's go together to solve it together. Now solution, you have 27 over 125, all in bracket, minus 1 over 3, multiply by 4 over 9, all in bracket, raised to power minus 1 over 2. The first thing is that let's solve in a way that we make this negative to disappear first before we start working. So how do we make the negative outside the bracket to disappear is that you go back to the word, the number inside that bracket. Then to make it to disappear, you will now change the numerator to become denominator and denominator to change to numerator. For instance, now this one 27 over 125, it will now turn to 125 divided by 27. You will see that I have changed 125 to the numerator. Then I've put 27 in the numerator. I've put it back to denominator. At that time, everything will now raise to power 1 over 3. The negative have disappeared already for that one. Then multiply by 4 over 9. This one also, I will do the same thing. It will now turn to 9 over 4. So 9 in denominator also will come to the numerator. So it will now be 9 over 4, all in bracket, raised to power 1 over 2. When you look at the 2 now, the what? The negative have disappeared. Now, let's now continue to simplify. Let's come to the 125 divided by 27, all raised to power 1 over 3. This one, you see that we have 3 here. It means that there is a particular number. You can multiply it together 3 times, a single number. That when you multiply it 3 times, it will give you 125. And that number is 5. When you have 5 times 5 times 5, that one will give you 125. So in that case, you are going to write 5 raised to power 3. When you come down to 27, the same thing will happen there. There is a particular number there. When you multiply it 3 times, we also give you 27. That one number is what? 3. That is 3 times 3 times 3. That is 3 raised to power 3. How did I know that it is 3? It is the power that is outside the bracket. Make me to know that there is a particular number. If I multiply it 3 times, I will get 125 and I will get 27. That is why I have 5 raised to power 3 divided by 3 raised to power 3. I will also come to the other side where we have 9 over 4 raised to power 1 over 2. We have 1 over 2 there. It means that there is a particular number, and again you will multiply it together twice to give you 9, and multiply it a number also twice to give you what? To give you 4. And that one will, for 9, it will be 3 times 3. That one will give us 3 raised to power 2. Divided by 2 raised to power 2. That one also will give us 4. And when you now look at it, you see that we have 5 raised to power 3. We have 3 raised to power 3. These two have common power. Then you can now write it as 5 divided by 3, all in bracket, raised to power 3, multiply by, we have 1 over 3 as power before, multiply by 1 over 3. So in that case, the 3, we cancel 3. You are going to have 5 over 3. For the other side, multiply. Since the 2 is power there that is common, you can also write as 3 divided by 2. Everything raised to power 2. Multiply by the power that is outside before. That is 1 over 2. So 2 also will cancel 2. We are going to have 3 over 2. So that our answer here now will now be 5 divided by 3 multiplied by 3 divided by 2. And when you look at it, you see that 3 can cancel 3. So now this one will now give us 5 over 2. So that is why if you leave your answer like that, it is improper fraction. So you can now leave your answer as mixed fraction. That will now be 2 whole number 1 over 2. So it is time for you to ask your question from all assessments, or that you answer my question. So you can call the studio line 07047003969. Once again, 07047003969. 3969. Hello, the caller.
Hello.
What is your name and where are you calling from?
My name is Ella Rockbat. I'm calling from Amuloko.
Amuloko. Okay. What is your question, or you want to answer my question?
I want to answer your question.
Okay. Here I have like 8 questions here. You can pick anyone so that to test the number 1. Now, simplify 2 raised to power 3 multiply by 2 raised to power 4. 2 raised to power 3 multiply by 2 raised to power 4.
2 raised to power 7.
2 raised to power 7. Correct. What is your name again?
Olaya Rokibat.
Olaya Rokibat from Amuloko. Thank you. You get my answer correctly.
Okay, sir.
Okay. Yes, you can still call the number and ask the questions or answer my question. 07047003969. Okay, all right. I'm still expecting your call to ask your question or answer my question on 07047003969. Now you see that this morning we have been able to look at indices, and this is the only aspect we can able to solve. Hello, the caller.
Hello, sir.
Hello, what is your name and where are you calling from?
Uche Success.
Uche.
From Iwo Road.
Uche. Success from Iwo Road.
Iwo Road.
Good. What is your question, or you want to answer my question?
I want to answer your question.
Okay. I have question 2 to question 8. You can pick anyone.
2.
Question 2. Simplify 5 raised to power 6 divided by 5 raised to power 2. Simplify 5 raised to power 6 divided by 5 raised to power 2.
5 raised to power 4.
Correct. Thank you, Uche Sose. You get it right. Thank you. Okay. Hello? Okay. Thank you, Uche. You get the answer correct. That's the 5 raised to power 4. Now, indices, that is what we are discussing since morning. We have looked at some laws of indices, and we are able to solve some examples in which the next time we meet on this show, we are still going to solve more example on indices, because we still have equation involve indices and some equation from indices. So now we have looked at that. Now, before we go, let's still solve these questions. Let's solve this question. But I'm still expecting your call from home. 07047003969. Yes, I'm still expecting your call to ask your questions or answer my questions. Now we have questions 4 divided by 24, all in bracket minus 1 over 2. 4 divided by 25, all in bracket raised to power minus 1 over 2, times 2 raised to power 4 divided by 15 over 2, all in bracket raised to power minus 2. Now, solution. Let's quickly solve this one. Now, we have 4 divided by 25, all in bracket raised to power minus 1 over 2. This one also, we can quickly make this negative to disappear by changing the numerator to denominator. So in this case, I'm going to write it as what? 25 divided by 4. 25 divided by 4. Then multiply by 2 raised to power 4 divided by, this one is 15 divided by 2, all in bracket, raised to power minus 2. I can also change this one as 2 divided by 15. So the negative have disappeared in two indices now. So we have 25 over 2 multiplied by 16 over 1 divided by 2 over 15. Everything also raised to power 1 over 2 and raised to power 2. So for the first one here, since it is 1 over 2 is over the bracket, this one will now be 5 raised to power 2 divided by 2 raised to power 2, all in bracket, raised to power 1 over 2, multiply by 2 raised to power 4 times 50 divided by 15 over 2. Everything inside the bracket raised to power 2. So this one, since we have the common power here, that is 5 over 2, everything in bracket raised to power 2 multiplied by 1 over 2. Then 2 raised to power 4 will give us 16, and that one will be multiplied by 16. Then we are going to have 15 raised to power what? Raised to power 2. But for this one, we cannot simplify 15. Rather than to write it as 15 raised to power 2 means 15 times 15. That one will give us 225. Then 2 raised to power 2, that one will give us what? 4. So from this side, we are going to have 5 divided by 2 multiplied by 16 over 1 multiplied by 225 divided by 4. So you can now cut this one. 2 we go in 16, that is 4. Then 4, we also cancel 4. We are going to have 5 multiplied by 225. So if you multiply that, that one will give us 2250. 2250. As we come to the end of today's section, as we come to the end of today's lesson, I encourage all SS3 students to revise what we have learned and practice more questions at home. My sincere thanks to our parents, the teacher, producer, studio manager, and the entire management of Oxygen FM 96.6 for your continued support. I am 96 of Oxygen FM 96.9 FM, Ibadan. I am Muyiwa Ogunrinola, your presenter. Join us again in our next edition for another exciting mathematics lesson. Until then, keep learning, keep practicing, and remember, success in mathematics comes through consistent effort. Thank you. God bless you.